Welcome, or hopefully welcome back to Reliability Matters, the podcast where we explore the people, processes, and technologies advancing the reliability of electronic assemblies in an increasingly complex world. For those of you who are counting, this is episode number 174. In this episode, we're diving into a topic that's rapidly reshaping our industry: artificial intelligence in PCB design. Far from a futuristic concept, AI is already being integrated into advanced design tools, improving efficiency, reducing design iterations, and helping engineers tackle increasing design complexity with shrinking timelines. Joining me today are two thought leaders who are at the forefront of this transformation. First, we welcome back Stephen Chavez, a senior printed circuit engineer with more than 30 years of experience. Steph serves as a senior product marketing manager at Siemens EDA, where he helps drive AI adoption in PCB design workflows. He's also the chairman of the Printed Circuit Engineering Association, or PCEA, and a PCEA and IPC certified master instructor trainer. Steph recently authored the article AI in PCB Design, It's Already Here, which forms the foundation of today's discussion. Also joining us is Dave Wiens, product manager for the Expedition Enterprise portfolio at Siemens EDA. With decades of experience in electronic design automation, Dave is a recognized expert in digital transformation and design innovation. He brings deep insight into how AI-driven tools are streamlining everything from system-level design to manufacturability, while empowering engineers to focus on innovation rather than repetition. We'll unpack the practical applications of AI in PCB workflows, covering predictive design, simulation, acceleration, and how these advancements are improving both reliability and time to market. If you're wondering what AI really means for the future of design and what it doesn't, you'll want to stay tuned. Let's get started.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Steph, Dave, welcome to the program. Thanks for being my guests today.
Thank you. That was an awesome intro.
Yeah, awesome intro. It's definitely a pleasure.
What makes it awesome is your accomplishments. My gosh, I feel like I'm talking to the kings of board design here. So it's great to have the two great minds in this subject on the show. Let's start with this. Steph, you stated in your article that AI and PCB design is no longer a future concept. It's but actually a current concept and a current reality. What triggered this shift? And besides just the evolution of AI, why now?
I think the biggest issue we're seeing is that in the industry, there's a gap that seems to be growing with the workforce, the demand in workforce, and compared to the available engineers that we have in the industry available today. And then that gap of industry engineers that are retiring. And so you have new engineers coming in that there's just not enough of them. And the old engineers that are leaving with this knowledge of and experience. And so the question then becomes for the EDA or for the industry is, how can we adapt to this growing gap? And how can, from an EDA's perspective, the tool vendor, how can we provide a tool that helps young engineers or less experienced engineers come up to speed faster and basically do more with less, because that's what's happening. And that evolution is what we're seeing and experiencing now. And I know that David spoke of quite a bit on this, and as he and I both hit industry conferences and lecture on this topic, it's the gap is just growing. And so the question is how do we respond to this, and how do we adapt to the new normal of the evolution of, it's just, we're having to do more with less. And how does an engineer go from a tool that maybe he doesn't pick up every day, rather than it's infrequent, and how can you get up to speed faster? How can a young engineer come out of college and be more of a return on investment employee faster, and be able to get up to speed quicker? And that's the key here, is where AI is now. We're utilizing AI to bridge this gap.
Yeah, I think there's definitely a generation gap here, like with any technology, right? There's always a generation gap. If I want to learn how to, when I first started this podcast, for example, I didn't know anything about audio engineering, or, I knew how to edit video, but I really didn't know about, what do I do to start a podcast? So I went on YouTube, and I ended up being taught by 13-year-olds. Yeah, I'd see a 13-year-old, and I'm like, nope, not going to watch that one. I'm looking for a guy my age to teach me how to do it, and there are no guys my age that can teach me how to do it. So I ended up, swallowing my pride and watching 12, 13, 14-year-olds, teach me the tips and tricks for, all this stuff. But I would imagine that the more experienced engineers, AKA older engineers, probably have a little bit more reluctance toward this technology, and maybe for two reasons. Maybe one is the perception of job insecurity, and the young people, if they're taught in college this tech, then that is all they know. I mean, the tools know more than they do, and that may or may not be the case with more experienced engineers. They may know more, and they certainly have a lot more tribal knowledge than the perception of AI. Dave, do you have any input on that?
Yeah. I mean, inertia is a beautiful thing, and it's a terrible thing. Inertia is what keeps us doing the same thing we did yesterday. We know the pain we're facing, but we know the results of that. We know how long it takes to do design. And so it keeps us doing the same thing we did. We've committed to our managers that this is how long it'll take. We know it'll take that long, even though there might be a technology that cuts the time in half. Our managers don't expect it, so why should we surface it to them? So in that context, AI is like any other automation that's come along, over the last 10, 20 years, in the sense that, or new technology process, introducing verification earlier in the process. Hey, that looks a lot like an extra step. Why would I want to do that? Well, it's because it cuts design respins in the end, and it costs less, but it's a functional change. And so that's not to say at all that engineers are not individuals that want to try out new things, but it just states that the business imperative, is on repetition, on predictability, and sometimes that works against adopting innovative technologies.
And I talked about maybe one of the hesitations, particularly for more experienced engineers in adopting this technology, is a bit of insecurity. Are there other factors that create significant reluctance to engineers when considering the adoption of AI within the design world?
I would make this comment that a lot of senior engineers are, in their ecosystem, they may be the big fish, meaning that they come with a lot of legacy experience. Then you get some young engineer who's coming out of school, whether he's a few years experience or he's less experienced, but yet his level of acceptance with automation or utilize today's advancements with latest best practices. That older engineer potentially feels more threatened. So therefore, they're going to stick to what they know, because their level of success that they're able to do and deliver is in their comfort zone of where they're used to being. And then, as Dave mentioned, is that there is expectations to deliver the product at a set period of time and what our cost is already going to take. Therefore, there's no urgency to change in the manner of how they deliver it, because they're okay with the level of success that they're having. And most of the time, especially my experience with Milero, no customer is going to pay a company to increase their efficiency to deliver their product, to implement a new process for their own evolution, so they can go implement that to another customer outside of them. They're paying, for example, company A to deliver their product. They don't care about company B, C, or D. They only care about company A. And so when we think about the reluctancy to change, it's all about what is your comfort zone and how well you feel with what you deliver. And stepping outside of their comfort zone, especially for someone more seasoned that is set in their ways, they're less likely to adopt that because they don't want to go from being the top dog. All of a sudden now they're second, third, or fourth tier when some younger kid or younger engineer comes along and is dominant because he's adapted to the new digital age.
Right. And is maybe viewed by the bean counters as far more efficient,
Exactly.
right? The projects go faster. They can complete 5 projects in the time that maybe it would take to complete one without the tools. Can either of you elaborate on how AI addresses the growing talent shortages? We talked about maybe reasons people wouldn't adopt it, but for reasons that maybe one should consider adopting it. How does AI affect the growing talent shortage and workload challenges facing PCB designers and teams today?
Yeah, Mike, in addition to what Steph was talking about, the uniqueness, we were talking about reluctance to a degree. One of the things that engineers have to understand with AI, like for the basic cases, it's just like any other automation. You treat it just like any other automation. But AI does bring in some unique aspects that have to be considered in the process. It has the potential, for instance, to hallucinate things. It has the potential to be rather sycophantic in the sense that it always wants to give you an answer, even if you don't deserve an answer. And so, my personal experiment, if you want to try it out, is ask something like ChatGPT to tell you the number of kinds of AI there are, and say, tell me the 2 kinds of AI, tell me the 3 kinds of AI. See how far you can go before it says no. There aren't that many kinds of AI. It's going to give you answers because it wants to be right. It wants to tell you things.
It's all about the prompt. It's all about the prompt.
Exactly.
Right? That's
exactly.
Bad prompt, bad answer.
Exactly. And that's ChatGPT, and that's not functionally an engineering tool. But what it's introduced is the need to consider quality of results, and quality of results are always critical to engineers. But it's a tool that basically in more recent years has gotten a bad name because of things like ChatGPT. We've had AI in our products for, 5-10 years, and didn't make a big announcement about it just because it was another technology, another automation. It's more recently that we started talking about because the industry is more interested in it. We want to talk about how. But just like we don't say, hey, by the way, we introduced a new feature with C++, saying, hey, we introduced a new technology with AI, functionally, it doesn't really matter. It's a new technology. It introduces some value. And to that point, the value, you asked, follow up, what was the value? It brings 2 things. One, the ability to accelerate design flows dramatically. That's the goal. I'll say that the reality is more incremental in nature, but it's still a productivity boost. And the other area is in design optimization, and maybe we can get to that later in this discussion. But ways in which simulators can be leveraged in new and different ways with AI to give you more accurate and more unique results that let you optimize your product in the end.
So I'm not a PCB designer by any training or even experience, but I have heard of the term auto routing. Is auto routing, was that always an AI tool, or was that more something else?
Dave, you want to take those from the tools perspective, and I'll follow it from a designer's perspective.
Sure. Yeah. AI has not been auto routing has not been an AI function to this point. Certainly, we've tried different heuristic routers over the years. We've tried all kinds of applications of it, but everything to date, the best-in-class routers today across the design spectrum are algorithmic auto routers, no AI included. Now, because auto route is one of the longest design processes around, within layout, it's looked at as a long pole. Hey, let's go tackle that. Just routing in general, not auto routing. And so it's an application area that's a hot topic. And that's where a lot of efforts have gone in, certainly to trying things. We're trying things as well. I'll tell you, really nobody's succeeding to this point.
Yeah, the reason I asked the question is I recall a conversation I had with a board designer quite a couple of years ago. And I was talking about AI and board design. And the reference was, auto routing isn't perfect. Therefore, at least his experience, it wasn't perfect. And he thought that was an AI tool, and therefore AI is not perfect. If auto routing makes a mistake, how many more mistakes if we start giving AI more responsibility? I'm glad you clarified that auto routing is a algorithmic programming tool, not reliant on artificial intelligence. Steph, you were going to add?
Yeah. So, when it comes to designers and their approach and their attack, they stay within their comfort zone. And what it comes down to is trust in the tool and then the willingness to give up control. And in reality, you're not really giving up control. You are actually controlling it even more, but you're controlling the horsepower in the tool. And I am one of the designers that will utilize automation when I can, but it only comes with experience to know when to use it and how to use it. And I ask this question all the time when I'm at conferences lecturing or at the universities lecturing is, how many designers of you in the audience auto route your board? And I'm almost guaranteed that 9 out of 10 will say 0, that they don't, that they refuse, and that's horrible. And, it's shocking to me because today's advancements in our tools that what we deliver today and this horsepower that's there, and they're not utilizing these capabilities. But you have to be intelligent about it. Yes, it takes more time to set up regarding your constraints, but in the end, it pays off. What you spend in the front end is speed and quality at the back end, and the ability to handle changes that come at you throughout the project. It's a difference maker. But you know what? I will just say this to the industry out there: those who still manually or interactively route, good for you. Stick with what your comfort. And know that, in my opinion, there's a better version of you out there if you choose to embrace automation today. But you know what? You do. Everyone makes their own decision. And I just think that with the automation that you're able to do a lot more, but it just depends on what you're designing up against. Is it, RF? Is it high speed? Is it power? And you can't do automation everywhere, but you have to be decisive and know when to pull that trigger and how to use it, because as Dave mentioned, it's about cycle time. How quick can you reduce the cycle time? If I can give a double E a week extra in the lab with his board before it's ready to the customer comes on site visit, how much value does that bring to the table? If I could shave off more time in the day to have a better work-life balance because I'm embracing AI or automation and using this to my advantage, I don't have to work 18 hours a day. I can work 8 hours a day and get 18 hours of effort. Why? Because I'm using the horsepower of my tool to my advantage. So this is what we see, a reluctancy of giving up control, or what they feel is giving up control. And then how well do they trust the tool? Because let's be real, auto routers of the past or tools of the past, a lot of us senior designers, we can still feel that pain of yesteryear, or decades of designing boards.
Sure, it breeds skepticism and deserved skepticism of the day.
Yeah,
I do think for those who think that AI is going to replace everybody, I think at least right now, and probably for the foreseeable future, it still takes an experienced, well-trained, educated board designer to even vet the auto routing or the AI.
There's still a educated human in the loop, so to speak.
Absolutely,
yes. Right?
absolutely.
Yes.
And instead of creating their proofing, their fact checking basically, and some of the effort is reduced in the actual manual work, and there's a new effort now in having to check all that manual work. Because I know, I would imagine human nature is such that once you get so good and so experienced at manually routing a board, for example, you don't I mean, you check as you do it. You don't have to go back necessarily and look at every, that every I is dotted and T is crossed. There's just this ritual. The inertia, as you said, Dave, kind of takes over.
But functionally, that's even impossible, right? I mean, manually doing a board, you might be able to ensure that the basic clearances are correct, but you can't ensure that it meets signal integrity, that it meets power integrity, it meets thermal requirements, that it meets mechanical requirements, manufacturability. That's just too much to consider, which is why there are verification tools all over the place. Sure. And, we as vendors have worked to integrate those more and more earlier and earlier into the process, making them, basically like your word check when you're in Microsoft Word and you make a mistake, it tells you right away and it offers recommendations to improve it. That's what we're trying to achieve in terms of real-time feedback. That even is impossible given, real-time performance. But still, that's the goal but you can't, so a manual designer just even can't functionally do that. And that's where automation kicks in. But to the point, I mean, you raised earlier about accuracy with AI. Again, we've been talking about auto routers. I'll be honest, when we first introduced auto routers, I can date myself. I've been in the industry for 40 years now. I started working on auto routers. I can tell you they weren't really good back then.
No.
And so maybe we created a bad image for ourselves. That technology over the decades has improved dramatically. But one of the things that we applied to that was, we tried to make those things production grade. They weren't toys. These were things engineers had to use on a day-to-day basis. And production grade, when you think about that relative to AI, it means, okay, number one, it's accurate. It's not producing a fake result of some sort. Now, even without AI involved, in auto routing, that's creating violations, right? That's not accurate. So it's got to be accurate. You've got to have a way to check it. Do you have another tool that can check it? With AI, hopefully you have that tool coupled up to it and it's checking before it even gives you a result. It's got to be general purpose. It's got to work across a wide spectrum of design. Today, AI, particularly applied to auto routers, is working on really, really simple things. And we can talk about why that is in terms of design data that's got to train on. But it's not applicable to a wide range of stuff. And so that in itself, maybe it works on one kind of design, but doesn't work on anything else. How do you know which one's going to work on when it's not? It's got to be easy to use. It can't take longer to set up than it takes to do the job manually or check at the back end to verify it. Okay, I'm the human in the loop, but I had to spend a lot of time setting up the AI, run the tool, and then checking the tool. That can't take longer than it took to do the job by hand. And I don't know. There's just security, generality. There's lots of elements that have applied to auto route over the years, and now apply to AI as well. You've got to, and if you want to take on a tool, ask your vendor. Have you applied these rules to this? How many designs will it work on? How many varieties of designs will it work on? How complex are the designs that it'll work on? These are all questions you should be asking.
Mm-hmm.
What are some of the most transformative ways AI is currently being used in PCB design, from everything from layout to verification and everything in between?
It's transformative. I'll tell you, when people think of transformative, they think of push the button and it does some magical thing. AI as applied today is much more incremental in nature. It's more behind the scenes. Like I said earlier, we introduced AI, in tools. One of the last ones was 6 years ago, and didn't make a beep about it being AI, and hey, it just worked, and people, and that's the kind of thing you want. You don't want to have to think, wow, this is some huge thing that's going to take over my flow and I'm going to have to do something different about it. So those incremental things have tremendous value, particularly if they're coupled up in a design process. And that's the majority of what we've got. But one of the larger things, you talk about verification, I've got an example for you. Now, this is in our Hyperlinks product. And it's around design space exploration. So when somebody they're doing early design, they want to set up the constraints, they're going to drive layout eventually, and they want to figure out, okay, what's the optimal configuration for something in layout.
Mhm.
So let's take, say, a differential via. That differential via, it's got a bunch of different elements. Okay, how big is the drill size, the pad size, the spacing apart? Do they have shielding vias? What's the exit path on those? And all of those, form variables that you could consider. And so what does a typical engineer try? Let's say signal integrity is what I'm measuring. So what are they going to do? They're going to create that structure, and they're going to do one simulation at a time, trying to figure out what's working, what's not. Maybe they'll do what's called a sweep. They'll, over a range of values, they'll pick one parameter and do a range. The reality, if you look at all the permutations, if you said, I want the best possible configuration over all those variables, in that one example, I just did some basic math. Let's say 8 examples, eight different variables I had that I want to consider, and add sweeps on each of them. That could end up over 20 million permutations. Okay, that's 20 million different simulations I'd have to run at roughly, let's say 10 minutes. It's pretty fast on a simulation, but 10 minutes on, say, a 3D analysis, you're up in the hundreds of years.
Yeah.
450 years to be exact. Actually more than that. But okay, so that's impossible. Nobody's going to do that. So what they do just a few checks, try to get in the rough range, hope they're good enough. If they're not anywhere close, they're just sitting there trying this, try this, try that. It's hunt and peck, just continual search. It's never going to get there. So you take something that took 450 years, it's not reality. You never really know if it's accurate. With AI in a design space exploration case, we can give it a budget. We can say, okay, instead of 20 plus million permutations, let's just try 100. Let's try this many CPUs, and give it that same problem. And we did that, and it returned a result in 16 hours overnight. So what we did there was we took something from impossible to possible, right? It was not functionally possible to find the best value before. You just hoped you're in the right ballpark. And now you can do something that you can say, look, I have optimized this design for signal integrity. There is no better configuration for that design. And that has real value in terms of the margins that you're trying to achieve in your design process. That, to me, now the order of magnitude there, again, calculations, it was over 200,000 times faster. 200,000. Okay. Again, nobody's going to live for 450 years, so it's not a realistic comparison, but you can see the orders of magnitude improvements that are possible with AI applied to the problem.
Steph, anything to add?
Yeah, I think the biggest thing, and just to amplify what Dave was saying, is I think the biggest thing is it gives the engineer the potential to add like what if scenarios, so he can try some different things to see what is going to work, and he can do this faster within the project flow without really taking a hit on the project duration overall. Because when you think about, in the end, they're trying to deliver within a set period of a project schedule, and under a specific budget. And how do they do that, without occupying too much budget and too much time in the schedule? So this is where it will definitely help.
We talked about simulations. Of course, no one wants to wait 450 years. But in terms of predictive analysis and simulations, how accurate are these AI-infused tools? And how do they impact first pass success rates, maybe compared to prior to AI?
Well, accuracy, let's see. I mean, for things like simulation, first of all, you start by measuring the accuracy of the simulator, the core simulator, nothing to do with AI at that point. And you have to trust your core simulator. Now that means doing correlation studies, and that's established art, right? Anybody that wants to use a simulator has made a physical prototype and measured the real results in the lab against it to trust that simulator across a wide range. So that in itself, in the case I gave anyway, that's not the accuracy problem. The accuracy, meaning if it produces a result, it's going to check the result itself for starters and say, okay, this is within the range that you specified. Now, the question of whether it was the best option, hey, I gave you the promise that this was going to be the best option possible. Well, okay, again, you can't run something for 450 years to check my work. So what you can do instead is pick simpler permutation configurations, pick something with less sweeps, with less variables, and try that out and say, okay, did this solution, in something that I can run in my lifetime, hopefully not, more than a day or two, across all permutations, does the thing return a result that's as accurate as it says it is? That's the way you can measure it there.
Do you see a day maybe in the future when the 450-year scenario could be reduced through quantum computing or whatever to maybe 450 minutes or 4.5 minutes or 4.5 seconds? Do we see, right now, if we went twice as fast, you're still looking at 225 or, whatever, 200 plus years. So that's, we need 1,000x faster, even more than that to make it within the realm of reality and efficiency. Do you see that will happen?
I think there's both the horsepower of an individual CPU getting faster, and there's the ability to split a problem up into multiple CPUs that exists today. Both, the multi-CPU. In the example I gave with 100 permutations and took overnight, that was with a single CPU. Boy, if I targeted that thing in multi CPU, I'd already have gotten it a lot faster. So there are technologies in play today, and we do that with things like our auto router. We can distribute the auto router across multiple CPUs and bring the results back, and then and stitch them all together. So that kind of thing has existed, frankly, for quite a while. On the simulation side, it's also been there. As long as you can take a problem, like say one of those permutations, that's a given problem. You can break it apart, send it to one CPU, send another part to another CPU, and as long as you can break the problem apart, you can already get some of that horsepower. It's possible, but certainly things like quantum compute, there's lots of potential there for acceleration of a task just with computer horsepower.
So, Steph, tell me more about predictive AI's ability to anticipate design commands. How much productivity gains are teams seeing with this feature?
So I think one of the biggest things is that you'll see, especially engineers coming up to speed with the tools, is it's bad enough that the projects add enough stress to the individual or to the engineer. Where we see the predictive commands or predictiveness of this AI coming into play is that it will allow the engineer to focus more on getting up to speed faster, so he could be more innovative. So he's spending less time fighting the tool and rather fighting the variable or the equation that he's up against, the design content that he's trying to create. So if he spends less time fighting the tool, and then AI is helping him understand his flow of what is next and what it foresees is, hey, you're doing this, and the last time you did this, and this as well. Do you want, so it's already thinking ahead of you to help. That allows you to be more innovative, so that way you can truly be creative in your engineering versus you're just fighting the tool. And now fighting the tool and fighting your challenge, it's very, very difficult. And as the evolution is unfolding now, we are seeing engineering teams that are really seeing this predictive AI be more enhancement to what they're able to do and what they're able to deliver, and being able to deliver in a less amount of time.
Generative AI now allows querying of data sheets in natural language. What does that mean for procurement accuracy and component selection speed? We've come a long way from catalogs on the shelf, right? DigiKey catalogs and all that stuff. I would imagine one thing AI is good at is devouring published material and forming associations.
That's one of the areas. I mean, again, we talked up front, why is AI, why are we talking about it a lot more? And one of the primary reasons is because there are tools like ChatGPT, OpenAI's got them, Microsoft's got them, Amazon, Google. They all have these large language models that have been trained to provide natural language, dialogue. You can put in a question, you can get a response back, and that technology, that basic technology, is applied to a lot of different things. We've applied it to a lot of things, like this capability to query data sheets, like the ability to provide in-tool documentation assistance. Hey, how do I execute these commands? And they'll give you 1, 2, 3 step, just directly in the product. That's all with basic trained models. Nothing really special. The only fine tuning we do is we train it with, say, the data sheets you got open, or we train it with the documentation for the product that you're using, and not the previous version, or not a different product from somebody else. So that's it's a pretty simple thing to train that. Now, in that particular case, though, that to me is an incremental improvement kind of thing. That's removing the data sheet thing. Yeah, certainly. We went from the days of, how many catalogs can I stack on my shelf, to the joy of getting a new one so you could recycle the old one.
Yeah.
A
lot of doorstops are old catalogs.
Oh yeah,
right?
a lot of exactly. And now everything's digital, so we made that massive leap, but frankly it wasn't a very big leap, and so engineers still have to go crawling through all of those data sheets. And so that's a pain. There are other technologies applied to that problem that involve AI. For instance, we've integrated supply frame technology into our flows. So when components are doing that basic search and compare on components, they see immediately the availability of those parts, the popularity of those parts, the cost of those parts. That is provided to us through extensive analysis done with AI. So AI is applied in different parts of the problem. But I got to be honest with you, just to put in a plug for something that's not AI, the reason why we're all sitting here using AI to crawl data sheets, and it's not just, an implementation we did was, hey, I've got a data sheet up, give me an answer on what, a particular parameter is, faster than I can crawl the entire data sheet.
Sure.
But there are other applications. People are using it to create footprints and symbol data and things like that. The reason everybody has to do that is because the component vendors are giving us that derived artifact, meaning a PDF, as the only means of intelligent data. What they could be providing, there's now a standard out there, there's a JEDEC standard, I think it's JEP 30, that provides an intelligent digital twin. And that intelligent digital twin, if the device vendors, all of them, provided that to engineers in the environment, there would be no AI necessary. Imagine that, you get the footprint symbol, no more library creation. You get that data directly passed to you from the component vendor, and no PDFs needed anymore for data sheets. That's a wonderful world, right? No AI necessary to accomplish that. So it's an example of where automation and digital twins can be applied to improve the process, without even the magic of the latest buzzword, AI.
Yeah. Well, today more than ever, data privacy and intellectual property, or IP protection, are major concerns. What reassurances can tool vendors offer to protect proprietary design data?
Wow, that's a really good one, because in the mil-aero, that's in that sector specifically, that's always a concern. And now with the evolution of AI, is how do we unfold this, and how do we know our data is protected, and how do we know AI isn't going to potentially expose or cause a leak? And that's the challenge. And Dave, I think one of the many things I've heard you talk about is our security and what we're doing here at Siemens and overall for AI. And I'll let you take this, but I at least wanted to share my experience at mil-aero, is that it is a huge concern of who's interacting or who has access to the data, and how are we locking it down. So we could utilize these cloud-based services to be extremely effective on global teams.
Yeah, I'd say, I mean, well, for starters, let's just say first of all, pretty much every customer conversation at some point turns to AI. Let's be honest, that's what happens. But the conversations have more recently shifted towards those kind of IT questions. I just a couple weeks ago produced a list of the AI that we had and answered some critical questions. Number one, whose data did it use? Does it use the customer's data or does it use somebody else's data? Number two, where does that data go? Does it stay on my desktop? Does it stay within the corporation? Does it go to the cloud? How controlled is it? So those two things. And then there was really a third one, which is what does it cost? In the sense that AI has the potential to be a variable cost. A lot of AI that you look at there is based on the consumption model. It's based on number of words, number of runs of something, and that's not new. Anybody who's had to deal with high performance compute has had to deal with that consumption model, but that's a variable that's being applied to AI as well. How much is it going to cost me to leverage this technology as a variable cost when I'm used to a fixed, CapEx on my budget. So IP security, where's my IP going? Where's it going? Sorry, what data is going? Where's it going? How much does it cost? One more, patent infringement.
Oh my gosh,
again,
that's a good one.
The risk of open AI, let's say AI that's been trained on the models of the world, is that you're going to use something that somebody else has created. Now this is all the buzz. This is why New York Times sued OpenAI amongst others. IP artists are suing these guys. Their IP was openly crawled without their permission.
Sure.
Now you can, their argument is it's out in the industry, it's out in the world. It's no longer really yours to, and so it can be leveraged, and we'll let the courts decide that. But the other side of it is really not up for debate, and that's if you use somebody else's stuff, at some level and at the design level, what kind of patent could they have created in the design world? And did you violate that in any way? Now, previously, the way that you would do that is you'd take a product and you'd tear it down and you'd find something cool and you'd utilize that in your next design, and you maybe not realizing you're violating a patent there. Now, right. AI has the potential, if it's trained on a bunch of different data, to do the same thing. And this gets back to the question of where's my IP going in the first place? If I can steal somebody's data, how can my data be stolen? And utilized in somebody else's products.
Yeah. What are some of the limitations? What are some of the limitations that AI still faces when it comes to nuanced engineering tasks like EMI control or thermal optimization or anything like that? Well, there's known good simulators. Again, it's back to the same thing. It's not so much. I mean, you're asking about EMI and thermal. I could apply the SI case. The simulators themselves, like I said earlier, are not the rare thing. It's they're not the unique aspect here. Yeah. It's the way in which you're applying those. I will say with AI, a nuance is the extensive model training that's required in certain applications. Say ones in which design artifacts like schematics or layouts are created, and they're a model that's created, and you have to. People are talking about hundreds and hundreds of designs that are necessary to train it, but it's not the sort of thing where you can just turn it loose on you're a large corporation, you've been doing engineering work for 30 years, you can just turn it loose on all the designs you ever created. It doesn't work that way. A rigid design, the rules for rigid design are different from a rigid flex. Power supply is very different from a high-speed digital. There's a lot of variables that come into play, at ITAR versus a not ITAR. If it's trained on an ITAR model, you better not be using that on a non-ITAR design. So those categorizations, and let alone just the design constraints, changed over those years, so that you really can't ensure that a model that was trained
on any set of data, is going to work for every single design. And so that's where a lot of work is going on right now. How do I need to categorize these into proper groups to define models that'll work for me?
From a board designer perspective, Steph,
I think
what do you see limitations are?
I think it's the way I see it is very similar to what we were talking about auto routing. AI is a tool. It's a lot of horsepower. You got to know when to use it and how to use it, and that's the key. And trusting that how are you using it and the results you get? Is it what you want it? And does it meet your pocket or your requirements? And that's the key. And when I think about what it can do is, you still need the human oversight. You still need a human intelligence behind it and how you control it. And that's when we think about the reluctancy of engineers embracing it, is that I'm just better off staying in my comfort zone and doing it myself than letting AI or trying to embrace AI, because I don't have the time to fiddle with it, because I got to deliver my project. I got to deliver my task, and I only have a set number of hours that I got to do. And that is the challenge. So therefore they stay with it, because it's an unknown variable. And as an engineer, our goal is to minimize the risk as much as possible when we deliver our product to fabrication. And how do we do that? And, AI is helping us, but with its being newly embraced or being new into design, there's still a learning curve, or there's a lot to be hashed out. And the capability is there, but it's not. It won't replace a human yet. That's without a fact. And the quality that you get from a human routing or a human designing, it's not there. What it will do is it will allow the engineer to replace a lot of mundane tasks, so that way he can focus more on what is critical and to get up to speed faster, and to deliver a better quality product if he embraces it and uses it to advantage. But at some point, you have to take a leap of faith and give it a go.
I think it's probably less of a discussion about limitations and more of a discussion about expectations, right? If our expectations can grow faster than AI technology, for sure. And it's not like a defect in AI.
Yeah.
It's really a defect in our expectations. Like, if it can do this, then it's got to be able to do that. And that is, has no ceiling on it. You'd mentioned, I believe in the article, you'd mentioned tools like Hyperlink's DSE using surrogate models to reduce simulation times. We've talked quite a bit today about simulations. Can you walk us through how that process works using those tools?
Yeah. Well, go ahead, Steph. Go ahead.
No, go ahead, Dave. Go ahead, because you'll be able to give a better perspective from the tool side versus me from the design side.
Well, I was going to say I already talked about it, but in the example I gave with design space exploration, the core process, of simulation acceleration, surrogate models are an area that, you can say, surrogate is the latest term for it as applied to AI. Without AI, there are things, we've talked about reduced order models for forever, synthetic models. These are models that aren't as detailed as they possibly could be at reduced order, right? ROM models. That's what the description is. And as a result, their results might not be as accurate, but they're going to run a whole lot faster. And so the world of surrogate modeling as applied to AI says that, okay, once I've done a basic design space exploration, now I can create surrogate models from that space and run future simulations even faster with even faster models. So that's the idea, that you take approximates from the data space and you use that to run even faster simulations. So that's, it's getting the whole process going even faster. But functionally, the idea of that kind of modeling, surrogates, synthetics, ROMs, is not new. It's just being applied to AI now.
How should companies approach training or customizing AI models for their specific workflows and design challenges? That's a big question.
That's a very big question, because
Yeah.
when you think about, companies are going to stay within their pocket of the level of success they have. And the question then becomes is, what is the funding to evolve and change? And are they willing to invest in that money to see a return that may take 5 or 10 years to really get an impact, or maybe sooner, who knows, depending on their ecosystem, their respective ecosystems. But that's what it comes down to, is how much are they willing to go all in to embrace the evolution of what they have right now and their level of success is, or are they okay with what they have and the legacy ways of doing things? There's really not a need to change, because their leadership or their culture environment is, there's no really threat, no need to change, because we're okay with servicing our customer. We agreed on a timeline, and we're able to meet it with what we are doing today. So
I'd add to that, when it comes to training, I mean, you sit here and think, okay, wow, AI, I'm going to have to spend a lot of time up front. It's back to the example where I said, look, if it takes longer to train something up front, to set it up front, run it, and then test the results at the back end than it does to do it without. Obviously, you're not going to do that. But a lot of the AI, again, we're focused on smaller incremental tasks and things. That doesn't even need training to begin with. The process prediction that we introduced, that comes with a model out of the box. We trained it. Now, if you don't like our design process that we trained it on, you can flush that model and spend some time training it yourself. But that's your choice, right? You can use the thing right out of the box, and it's just going to follow you from that point forward and learn from your process and eventually adopt that. So it's a simplified model training. The data sheet example, the documentation example, require no upfront training whatsoever. And same thing with the design space exploration, no training up front, decoupling optimization, no training needed up front. So there's a lot of examples of AI that have been applied today. We can talk all we want about, the training effort. But when it comes to really simple examples, leveraging, again, those large language models that are out there, that training's happened somewhere else. Engineering doesn't need to take that on.
What advice would you give to smaller design teams who may be skeptical due to a perceived high cost of AI implementations? They're not a giant design house. They're a small, 2, 3, 4, 5 person design team in a smaller company with more shallow pockets. Is that
I think
perception issue, or is it real?
No, I think with the smaller teams, actually it pays into their advantage, or plays into their advantage, because they're more agile and they're more adaptable. When you think of a large ecosystem, a large enterprise company, it's a lot harder to implement change and embrace a new methodology, whereas a smaller, younger, maybe small SBU or SMB maybe more willingness to embrace this, because they can do more, and there's a potential for them to do more and recover faster if for whatever reason they feel it's not working for them. But I just think when I think how teams can embrace this, and I just think a smaller team, there's more all in, so to speak, because they're smaller and they're more agile to embrace this, versus a larger ecosystem that's a little hard to kind of herd the kittens, so to speak, and get everyone on the same page and into a change an ecosystem that is already in place, that has been there for decades, and they are achieving a level of success. And so it's hard to change a cultured mindset that is already there within that ecosystem.
Well, that's where good is the enemy of great.
It's also a differentiator, right? It's a small company. They need to differentiate themselves. Leveraging advanced technologies is one way to do that. I'd also add to that, again, a lot of examples of AI don't need a lot of training up front, so small teams can adapt those as well as large teams. That's not a big differentiator. When it comes to some of the training, though, to create actual design artifacts, where I was talking earlier about, hundreds and hundreds of designs, unfortunately, it's not a democratized technology in the sense that the larger the company and the more designs, assuming you can categorize them appropriately, the better off you may be. You've got more data at your disposal, unless the industry figures out a way to anonymize the data, to federate the data, and share it widely. And that's exactly what's happened again with these LLMs that have been created, again, crawling the world of data, and you see the result. But that's how they did it. That's how they democratized that technology, was by training it, somewhere else on somebody else's technology, so that everybody could take advantage. When it comes to design data, you've got what you got. And if you're a small company, if you're a service bureau, you probably can't use one customer's designs to train a model for another design. There's all kinds of rules that start applying there.
Yeah, that's a good point. Just two more questions. You talk about AI empowering engineers rather than replacing them. What new skill sets or mindsets even should engineers develop to thrive in an AI-enhanced design environment?
I think the biggest thing is to be open to be able to do more than what you see, like with a horse with blinders. You're only focused on layout, whereas now with the AI at your advantage or at your disposal, so to speak, you're able to do more from a broader scale. Like I can now quickly get into doing EMI or EMC checks on my design. I can do DFM checks, so that way I have a more manufacturing driven design versus I'm tossing something over the wall and I'm hoping that everything goes good. But it starts with collaboration with your supplier from the very beginning, and then utilizing these tools to your advantage, or this new methodology to your advantage with AI, and embracing it to be better and faster. And so that way you spend less time searching a tool or a tool that you don't pick up that often, to be able to get up to speed faster. And that way you could become more productive sooner and more innovative and creative throughout the entire process.
Yeah, great point.
Yeah, I'd say it's act like an engineer. Be curious and test the results like hell, right?
Exactly.
You try something out and you test it. You test it again. And that's the way. Same thing with AI. And the only other thing I'd add is going back to the some of the unique aspects of AI. Engineers might need to understand more about where their data is going, how it's being utilized, some of those IT type questions. That functionally should be something that the vendor provides. The vendor tells the customer, look, this is how it works. We do that today when our technology goes to the cloud. And so it's no different with AI.
That's you heard it here first, folks. There's a new IPC standard. It basically says act like an engineer and test the hell out of everything. That's 1.0, 2.0. Those are the two standards. Final question. We'll get out your crystal ball. What do you see as the next major breakthrough for AI in the electronics design space over the next, say, 3 to 5 years, which is basically 500 years of at the speed AI is progressing?
First of all, again, I studied AI 40 years ago. It's not really moving that fast, to be honest.
Okay.
It's moving that fast when it comes to large language models as applied to some of those use cases we've talked about. That's where the investment has happened. And trust me, they're investing tons and tons and tons, more than Siemens can invest, more than our competition can invest. So that's the area and that's the application. So as much as any of us can leverage those models, we can get improvement out of them. But when it comes to some of the other things, it's going to move at a slower rate. So, and that's when it comes to things like, for complex designs anyway, there are startups out there that are promising full design synthesis today, as in you put a requirement in, you get a board out. They exist out there, but they're for really, really simple designs trained on open source data. And so that's, and without a whole lot of constraints applied to it, signal integrity, power integrity, all the rest, manufacturability. Applying that sort of, those sort of constraints and getting real world responses in real time is going to take a while. I projected out somewhere between 5 and 10 years. Now, am I being pessimistic? Perhaps. There are some changes. I have been impressed with the changes, as you know, Mike, in the last few years with some of the things. But I still, there will be tasks that will be automated. More and more, simple things like placing groups of parts and things like that, clusters of routes, not full that push button, everything's automatic. It's not going to happen, anytime soon.
I would agree with that. And my take would be is that, where I see us evolving to is that AI is not going to replace the designer or the engineer. Who will replace the engineer is the AI, the engineer who is embracing and using it to his advantage. No different than, when we first started utilizing automatic placement or some auto routing feature capabilities, is that automation. So that's what's going to end up happening is the engineers who accept the evolution of our tools and use it to their advantage. Those are the ones who will replace the engineers who don't evolve. And unfortunately, that's the evolution of our industry is, when is to try not to become obsolete and to continue sharpening your skill set, not just as an engineer, but your skill set in designing with the tools that you wield.
And speaking of tools, for my audience who wants to get more information on the design tools and everything we've been talking about, if you are watching this on YouTube and you look down here where it says see more, you'll see some contact information for Steph and Dave. And if you're listening to this on your favorite podcast app, when it's safe to do so, look at the podcast app and the show notes will contain that same information. Steph Chavez and Dave Wiens, thank you so much for being my guest today. My guests, plural, today. It's been a pleasure. And what I love about being a host of this podcast is I get to learn stuff. So now I have a little bit more stuff in my head. So thank you for help. Now that means something's got to go, because
no,
it's full, right? So I have to figure out what I'm going to throw out to replace with this. So thank you for enlightening me and educating me, and more importantly, my audience on this really fascinating and topical, relevant topic.
Well, thanks for hosting us. It was a great discussion. Appreciate that.
Is our pleasure, my pleasure.
Well, certainly mine as well. Well, that's another episode. Thanks for listening to or watching the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on your favorite podcast app. If you're watching this podcast on the Reliability Matters YouTube channel, be sure to like and subscribe to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of every month. A special thanks to the Printed Circuit Engineering Association's PCB Chat at PCBchat.com and Ascendo Reliability at reliability.fm for syndicating this show. Thanks also for your questions and episode suggestions. Please keep them coming. I love to hear from you. Send comments or episode suggestions to mike@mikeconrad.com. Just remember that's Conrad spelled with a K. To learn more about the Reliability Matters podcast, please visit our website at reliabilitymatterspodcast.com. Once again, thanks for listening or watching. Until next time, keep learning, keep doing it right, and remember, reliability matters. I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.